I'm really, really happy to finally be here. Maybe you don't know this, but this talk has a delay of 3 years, exactly, around this time, because it was supposed to have happened in 2020 in Sydney, when it was firstly accepted for the SREcon, hence the T-shirt. But I always felt like, this is actually very interesting content. Please don't take this as the content is outdated. As far as I know, and I'm hoping that you will still consider it fresh enough, and I guess we'll see throughout the talk if this is something that you can relate. Let me start first with the usual context setting so that you also figure out that from my personal experience, the size, the scale may or may not relate directly to something that is familiar with you. So as of today, I am working for a group of companies called Delivery Hero. I don't know how many of you may be familiar with it, but this group actually is a group of many different companies, and it runs 7 platforms around the globe. Those 7 platforms are powering the business around a little bit over 70 countries. One of those brands, at least for the locals, you might be familiar with Foodpanda, for example. You may have seen some of those things going around. That's one of the many companies of the group. And to give you the sense of scale, the number of teams and how complex this is, there are over 5,000 employees in tech alone doing all of this, many different teams in many different tech hubs around the globe, and those are the colleagues that are eventually also on call. Many of these colleagues are on call, as the majority of you here today. I don't want you to think a lot about this, but hopefully this gives you a sense of scale, many teams, potential large distributed systems, because that's how we do it nowadays. I think that's an important ingredient as we will move forward in the call. But I always figure that the best way to try to get you in my mental model is to start with the journey. A journey that starts with that. Who wants to guess what that represents? Exactly. That represents a very big monolith. And I don't know how many of you were lucky enough. I was very lucky to have started with many monoliths, or those that never started as a monolith, but eventually became a monolith, because I think this is an important part. So this is the beginning of that journey. And I want to take us back to the age of the monolith. Because the age of the monolith was, well, we were running the monoliths, and monoliths had a couple of interesting properties in the sense that they were responsible for everything. Every request, every response would flow to it, and they would do everything. We all agree that that particular approach didn't scale, didn't survive for long. Even though there were attempts, monoliths could also scale horizontally. You could replicate monoliths. Eventually you would hit into sticky session problems, things like that, but you could make it work, okay? The reasons why monoliths were not really surviving were not so related. They did have a very important property that even today, hopefully everyone can agree. They were very easy to reason about. It was very easy to understand how a monolith worked. And it was also relatively easy to monitor, which is now starting to get close to the talk. How we were monitoring a monolith. This was also the era of the devs and the ops. I would argue that there was a good overlap there where there was the ops people and there was the devs people, and the ops would, I'm trying to simplify here admittedly, but let's, for the sake of simplicity, go along with it, that the ops will look at the boxes. Are they up? Are they on? And eventually they will look if the process was still running, and this was the ops responsibility. The rest is not my responsibility. And then the devs would eventually look at, am I receiving the requests? Am I returning the responses? I don't even think that at the time I personally didn't really care so much if it was doing the right thing. I just cared if there was throughput flowing through the system. We could also measure if it was fast, with averages no less, because this was the time where aggregating latency was very interesting. So monitoring the monolith was also simple, in my opinion. And we were also doing alerting on all of this. And eventually, we felt like organizations couldn't scale anymore. So we had to do something about it, and we did. We fixed it. That's exactly what happens to many of our organizations today, with micro, nano, whatever size of services. But again, your company may be different, okay? You may have less microservice, maybe it's not the Death Star. I'm not coming with a name, so this is how it was introduced to the world back in 2018. But I think it tries to represent exactly that. We went from that to something similar to this. It definitely is no longer just a single box doing that single thing. It's many of them interconnected, which comes with complexity. Again, this is not a talk about microservices, okay? But what is important is, how do we monitor this? I just told you how I think we monitor the monolith. And now I want to at least share with you how I think we monitor this. Before I go into that, how we monitor this, this is too abstract, many microservices related. So let me try to share a very typical operation in a potential distributed microservice. Hopefully one that you can all relate. Who, this week here at SREcon, order something online? Food, whatever, order something online. Not that many, but that's okay, because while you did that, one good example was you placed an order in some platform. Doesn't matter to do what, but you placed an order. Like the previous Death Star, I guess you can agree that there's possibly many involved microservices in that platform where you placed your order. Likely some front end and then something that was taking care of the checkout, and because, you know, data platforms and all of the things and some queuing, Kafka, there was a bunch of things involved, right? For absolutely guaranteed. There were many different services involved into that. So for the rest of the talk, I'm going to use this example so that we can stay on the same page. No pun intended with the title. But this is what you can expect from a typical modern place order operation. Your company may have less, your company may have more. It's not so important because the principles will be the same. How do we monitor this today? What are we doing monitoring and particular alerting? What are we doing in this regard? Well, along with that journey of microservices, we also did something very interesting as an industry, which is we introduced job titles as DevOps, we introduced job titles as SRE. The titles are not relevant because most of the time we just change the job title, they continue doing exactly the same. But they cost 30% more. The job title is not really so important. The important part is, what are they doing? And, no surprise, there is someone still checking if the box is up. We just call it pods now because it's nicer. But we still check if the pods are up. We still check if eventually the container, the process is there. We still measure error rate. We look at some load balancer ingress metric and we figure out how many 5XX are coming out of it and ooh, it's bad. And eventually we still measure if they are fast. How many relate to this? Those that are not raising their hand are not paying attention or lying. No, that was just a joke. So I think this actually represents today's situation with many of us, and I want to bring back the previous example, failure placing an order. Again, accepting that would be a good representation of a modern architecture, placing an order. The first question is, what happens today if one of those microservices in that distributed system, the accounting service, has an outage? What happens today? More than one alert will come up. That's what I think will happen. How many of you have found yourself in one of these boxes getting an alert for something that was not your microservice, your responsibility? Okay. Again, you may have a much simplified microservice architecture. That's perfectly fine. It's perfectly fine. But I believe in my personal experience over many, many years is that this is more common, unfortunately, than it should. And I call this the Christmas tree effect. Christmas tree because I compare it as many blinking lights, getting your attention. The only practical difference being that happiness level is not the same. And no one is getting any presents. Absolutely no one. So this is not great. And what it ends up resulting in is alert fatigue. Some of these teams are getting paged, eventually in the middle of the night, engaging into an incident response, just because the alerting quality was not so good, and this is not something that I can do, and terrible, and I hope that the next talk will be picking up on that. And now I'm going back to bed, angry, and maybe I don't want to do on-call anymore. Actually, the industry came up with a good guidance to solve this. This is not new. Symptom-based alerting, and I actually order these things by year where these publications happen. Symptom-based alerting is effectively the solution for this problem. You no longer focus on potential causes, like the pod is not available. You don't focus on those things. You focus on customer-centric, really strong signals where the signal-to-noise ratio is strong, and you will react to that. Because this will eventually capture the vast majority of unknown unknowns. Any other approach will lead to the Christmas tree effect. Any of these authors have plenty of guidance documentation how to solve this, in theory. Let's pick what could be, again, the same example with a symptom-based alerting approach. First, you need to find a good place where you have good signal-to-noise ratio. There are valid reasons for this. If you go too close to the customer, like on their mobile device, and then go in the subway, the network fails and this emits signal that causes too much noise, you are actually at the same situation of you don't own the network in the subway, okay? So you need to find a better place where the signal-to-noise ratio is ideal, okay? Which means likely not in the mobile device, but as soon as you start controlling that and you have enough domain context, then you likely want to put an alerting rule there. In this example, our example, it would be there. The checkout service where the operation place an order starts. So we would measure it there. And if we have an alerting rule there, and now we have the accounting service failing, you can anticipate this will eventually have a cascading effect and the checkout service will fail to place the order, right? All of these microservices will return errors and they will cascade all the way that it will breach that alerting rule. It works. Now no longer a bunch of them like before. The Christmas tree effect is no longer happening. You have one alerting rule being triggered. This looks promising. Symptom-based alert seems to solve it. Let's try it now if the payment service has an outage, which was also necessary to place an order. Once again, a single alert triggered. This looks really good. We just solved this very hard problem. Did we? Is there anything wrong about this? Well, what is wrong is that this page, this alerting rule, for whatever reason today in any tool, in any approach, is always statically assigned to the same on-call team. That's the poor team that is going to be paged now on behalf of everyone else in the company, which, by the way, can lead to you to bring back the knock and have someone doing the first level. Someone will hate their job. That's guaranteed. This is also not okay. In my opinion, this is also not acceptable. It seems that, as an industry, we came up with symptom-based alerting solves the problem, and we are still failing to come up with a way that we can implement that strategy in a way that actually solves the problem. No surprise, this is what this talk is about, right? I believe that there is a robust solution for this. And this all started a while ago with our good friend Charity mentioning in this thread about these so-called microservice organizations, which I assume it's all of us. And who is responsible for this triage, what I just basically suggested? Who is the first responder? Who does the triage? How do we then route that to someone that can do something about it? Well, that was exactly it. At that time, what I was doing together with my team was exactly an implementation that addressed exactly this. And we called it adaptive paging. Adaptive because it's never bound to a static on-call team. It will always derive who to page based on context. Very brief description. It's just a webhook, if you want. It's an alert handler that is actually triggered and is not assigned directly to a team, and it will leverage the causality property from distributed tracing and its semantic conventions to page the team closest to the problem. It will no longer page always the same team. It will derive knowledge to find out who is the one closest to the problem. And I want to tell you how it works. To be able to explain how it works, it's a very brief primer on distributed tracing because it's a key ingredient to this, and it has evolved. The first version that I gave this talk, it was still Opentracing as the logo everywhere. Thankfully, OpenTelemetry did not change much those semantics. There are some tiny things that have changed, but I try to make sure that they are fresh and up to date, okay? The relevant part for those that are not familiar about distributed tracing, this is a observability framework, if you want, that allows you to observe the end-to-end journey of an operation. So it can actually start there when the customer places the order, and it could traverse all of those different services that interacted in that journey. That's the end-to-end trace. Key components in distributed tracing that are relevant to take away is some of its concepts. The first one is a span. A span in distributed tracing parlance, OpenTelemetry, is basically what represents the operation. That particular operation, so place order would be the operation, and a span implicitly measures the duration of that operation. So that's what you have there. And a span can be enriched with additional metadata, and those today are called attributes. They used to be called tags, now they are called attributes. This is the second relevant concept, attributes. Attributes are key value pairs. This is basically it. You give those keys a name, and then you put a value there, and this is all attached to a span, so you can enrich an existing operation with a ton of valuable context, such as country or credit payment methods, things like that, that will eventually help you immediately when place order is failing. Can I derive something from it? Oh, it seems that Amex is failing right now. Things like that. More importantly, some of these tags, hence the importance of the semantic conventions, is they have a very well-defined meaning that everyone producing or consuming this type of telemetry agrees to. For example, the error tag. I think today is actually unfortunately different, but this was an old screenshot from Jaeger, the open source tool. Today, I believe it's called status.code. And these are some of those examples. All of these tags have a really well-defined meaning, which means everyone has a very well-defined expectation how to interpret it, what to do with it. This is very, very important because any tag that has the status coded value error, it means that that particular operation is considered to have failed. Even if its underlying HTTP operation, for example, returned a 200. GraphQL, anyone? GraphQL always returns success, even when it failed miserably to do its job. So this is actually one way that you can decouple yourself from the transport and still flag it, this operation failed. Sure, it's still at 200, but it's an empty result. There are a couple of more in this particular slide that are very relevant for adaptive paging, but this is it. This is the set of tags that are relevant for something like adaptive paging, nothing else. Another important thing that I mentioned only briefly in passage earlier was just the causality property of distributed tracing. Okay, what that means is that if place order is considered to have failed, and it also did a remote procedure call that is also considered to have failed, eventually this means that if I failed, very likely my direct dependency also failed. Or if your direct dependency failed, you can accept that I failed because of that. Okay, this causality property is very, very important. You don't get from disjoint monitoring systems such as metrics in system A and in system B, because that is just aggregated without the concept of in that particular operation. Last part that puts all of this together is the monitoring signals that you get from something like distributed tracing. You get implicitly from these, you get throughput, because all of these operations happen at a certain period of time, so you can automatically get the throughput, how fast this is happening over time. You also get latency measurements, because the spans measure the duration of that particular operation. If you aggregate over that particular operation for a period of time, you also get latency measurements. And you also get errors. Are they failing and how often? Error rates. I just mentioned 3 of the 4 golden signals, by the way. So if you don't have anything else, rely on these. They will do great for your observability approach. Let's get concrete now. This was the theory part. Now let's get concrete. And imagine that you have the checkout service, a potential service, and you will want to create a rule on a certain SLO threshold to alert you when this reaches 99.5%, something like that. The alerting tool is not relevant at all. I hope that is clear, okay? This is just one example, and even the criteria that to create the rule, your particular tool will be different, but that's not relevant, okay? It's basically, it needs to deliver the alert into a webhook, into an HTTP handler that could handle it, and that would be the adaptive paging handler. But let's imagine that you create this rule, and you put the threshold, and eventually this will be triggered when that threshold is exceeded. Every time that happens, you can always go back and query from your distributed tracing system, give me more traces, in the vicinity of the time that the alert was delivered. So you want probably the previous 5 minutes of traces, as many as possible. You want to get them, call them exemplars. Some of these tools actually already deliver this to you in the payload of the alert to point you that we found some of these operations that failed. You might want to have a look at these, okay? In this case, you actually want them. You want to query a couple of them because it's going to be exactly how adaptive paging works. How does it work? Well, as I said, it goes for every single trace that it collected in the vicinity of the incident, okay? And it starts by analyzing the metadata of the span, that particular operation that you started being interested. And you are interested in placing an order in the checkout service. So you're going to be looking at that one, and you're going to be looking at the metadata, the attributes, for specific values. In this particular example today, it's really just about error rates and failures. So what you want to do is you're going to be looking at all of the child spans that it did, and you are looking for the one that contains the status code equals error. That means that that one has failed. This is the one very likely to cause me to fail. And that's what you are looking for. If you had multiple child spans with error, that's one of the challenges that I will share then at the end, how that can be addressed. But to keep things very simple right now, you basically want to do this iteratively until you stop finding a child span with an error. That's it. You carry the path, you continue going all the way, following, traversing the distributed trace until you find a child span that no longer has errors. When you found this, you found the most probable root cause. It doesn't have to be necessarily the cause, but it will be closer to. And that's the whole promise here, finding the team closest to the problem. Which in the case, if you remember the diagram, that was exactly it. It was the update account operation in the accounting service. This was the one that was failing, which was exactly what I just said. So by alerting on the symptom, I'm revisiting the first iteration of trying to solve this by alerting on symptoms. We still have the rule exactly in the same place, good signal to noise ratio. We still have everything exactly the same, but now we have an outage in the accounting service. But now the delivery of the alert was to something like adaptive paging. What would happen? As you can already guess, now that single page, still just one, will be dispatched to the team that owns the accounting service. And that team will likely be closest to the problem. We'll see that their cache was evicted or their database exhausted, saturated, something like that. They will be able to do something. They will fix it very quickly, removing completely that first 30 minutes of theater, everyone pointing at each other who is causing it, because they will be eventually already being told that these traces have these in the payload suggesting exactly what's wrong. Just to demonstrate that this might actually work, let's see the second example. If the payment service now would have an outage, what would happen? And you can already guess, no surprise, a single paging alert will be dispatched to the team that owns the payment service. And this is it. This is really it. This is how simple the approach can be. By leveraging existing, easily available observability frameworks and tools, you can implement something as simple as this, like we did, and it worked very well. I also think that is very smart, but since you probably don't know Mr. Weller's charity, those are her own words. And I think it is a robust approach. I know that I am familiar with other approaches. The one that I just shared with you is one that just relies on something that anyone can take off the shelf and eventually go and implement. It did not come without challenges, and this is what I was trying to referring to earlier, that, well, my example is obviously very well crafted to guide you to a happy path, and what are the things that can challenge the implementation, and there are some. The first one is exactly, what if my traces that I'm analyzing have multiple paths of failure? Which one do I take? Do I go left? Do I go right? This would basically start violating the whole principle of the thing. And what we ended up doing was just go through all of them and keep a score. Keep a score to every time you find one that is the closest to the problem, you keep a score. And then at the end, if you have 50-50 distribution, fall back to page those two. It's still better than the Christmas tree. It's not ideal. And measure how often that happens so that you can also learn by re-instrumenting better the systems, because this is very unlikely to happen in real life, that two things fail exactly at the same time, contributing to the causality problem. It's very unlikely. But if that's the case, keeping score all of the different paths is the best way, and we found out that this actually eliminated more than 99% of them, and in the rare cases that it would happen, you basically page both. One of them has the same likelihood of being the one causing the problem. Or you extend the period that you pull exemplars to go and analyze. Eventually, one started as a consequence of the other one. The most interesting one, and this one is really cool because of the incentive system that it leaves behind, is, okay, that was a distributed system that was instrumented end-to-end. Every single service was instrumented with distributed tracing. If you have done this already, this actually can be a very tedious task to get distributed tracing, OpenTelemetry baked into all of your services, especially if you're an organization of over 1,000 of them. Ooh, this will take a while. Teams will eventually do it if they have the right incentive. One way to incentivize them is, if one of the services in the middle is not instrumented, the span context will not be propagated, which means you end up with two separate distributed systems when it comes to observability. So the furthest you can get is exactly up to the point where that particular service was not instrumented. You can hint something like adaptive paging to page the team that did not instrument. So you tell it that I was trying to do a remote procedure call against service X, and I failed. So I failed because of that. So let me page them because they are the ones not allowing me to continue. So they will get paged 2 or 3 times before they instrument the service. I can absolutely guarantee this was very, very effective. And the last part is, I told you that team closest to the problem. Well, team is not necessarily a service, okay? From my own experience, what I also found out is that you have services running, that's easy, right? What you may not have is a good solid mapping of each individual service that you have in your organization and who's on call for that particular service. So simple implementation such as a service registry that you may have additional metadata, like where is the source code repository, which team is on call, where's the documentation page for that. Even for many other useful reasons, I strongly recommend something like that. And I'm also very confident there are open source solutions for that, Backstage and things like that. So these were the challenges that we faced, that we ended up solving in different ways. And it gave tremendous improvements to the on-call life of the engineers. And this is almost the end. But first, some acknowledgement or a bit of my own mental model still about the situation. And why I think this is still very relevant, even if this talk was actually given at SREcon EMEA in 2019. It's now 4 years later, and I don't think the situation has improved. I've been personally seeking for why. Why? If this solution is just one of the some solutions that I personally am aware of, what is preventing us from making our own lives better? These things are relatively simple to implement. Anyone could go and implement them, but the vendors are actually not picking it up. They just give you a very simple approach of threshold, hood to page, give me a PagerDuty escalation and go. They were also present in some of the iterations of this talk, but the industry is not changing. And this personally makes me a bit sad because we all acknowledge the pain, but it seems that something's not picking up. I tend to make the analogy to unit testing. Maybe just 2 decades ago, unit testing was not as ubiquitous as it is today. People were not doing it. It was probably even seen as a waste of time, waste of money. Who doesn't do unit testing today? Because I like to see way more hands up. Who is doing unit testing? If you code in unit testing. I hope that the other ones don't are raising their hand because you don't code. In any case, I want to believe that everyone actually realistically, seriously producing code for production is writing unit tests because the industry already accepted this is definitely worth the investment. I see these 2 things exactly the same way. You write unit tests to increase your confidence at authoring time that your code will behave as it was being designed to. As you know, production is not exactly that because it is subject to the environment. Something like this gives you the confidence that it's actually operating as you intended to. So proper observability is not to slap more logs onto something. So I think that's something that the industry is still trying to figure out. Observability is not a simple term that the vendors can use and abuse for their own sale purposes. We need to be way more critical and demanding of what we expect to get from it. Something like distributed tracing for things such as a distributed system where you actually operate on transactions is completely different from someone that is managing infrastructure that obviously is looking at saturation signals. And that's okay. That is also has a place, but it's not the same. These two worlds are considerably different. So I think that's important to acknowledge and demand more, and especially do something more about how we want to work on this. I just said that the industry needs to pick it up. It doesn't mean that the industry is completely asleep. So even LinkedIn in 2013, I think at Monitorama, published a paper, very interestingly, very much in this direction, looking at different telemetries, logs, and things like that. Very cool paper. I don't remember the name, but if you search for LinkedIn Monitorama, likely this paper will show up. And more recently, this is really good, and I don't know the exact name, so apologies for the colleague, someone that is currently working at Google. Google now has a team dedicated to this. They are working on critical user interactions, or CUI, that are doing exactly the same thing, which is pretty cool. So they actually approached me recently saying that they gave a talk, and someone pointed them at this talk recorded in 2019. So you just did the same, and none of us knew about each other, which is pretty cool. But this is just to also acknowledge that it seems that there is fate. So the industry is not completely asleep, and something is coming, and I hope that things get better to all of us, especially those doing on-call. And with all of this said and done, now before I hand over to your questions, I ask you a question. Are we all on the same page? We are. That's the right answer. Thank you very much. Thank you for coming here today.